everybody, welcome to the homework helper, the last of the term. Unless I might do some of those for the review. We'll see. We'll see how this week goes. But this is the last of the new material in 9.9 here. The very first topic is we want to identify what type of function, and we want to be able to write explicit equations for it. So we're going to be given a linear, exponential, or neither. So to be able to do this, we kind of need to go back in the Wayback Machine of our brains and remember how these things are done. And so I'll do a quick little recap on what linear functions are. Linear functions are also known as arithmetic sequences. They behave very similarly, and what we end up having is we have some f of x is equal to our 0th term plus our common difference times our x, and our common difference is whatever number goes from step 1 to step 2 to step 3, etc. This is very, very similar to y equals mx plus b. Okay, it's essentially the same thing, where we have our m and our common difference are essentially the same thing, and our n sub 0 is the same thing as our y-intercept. So just kind of keep that in mind as well. Likewise, we're going to have exponentials, and these are going to behave the same way as our geometric, geometric, it's been a long day, geometric sequences. And the equation for this is going to be f of x equals our n sub 0 times our common ratio to the x power, where our common ratio is a number that we multiply by at each step. So we have to, knowing that, make sense of all of this. So what we're going to do here is we're going to start with this one, and let me get this thing in focus. All right. So what we need to figure out is we need to figure out if we are adding the same number each time. If we are adding the same number each time, then we know that it's linear. And I can kind of already see that that's not the case, but I guess I'll prove it to you guys. Because if I take my second term, so if I take my n sub 2 and subtract my n sub 1, that should be my common difference. So my n sub 2 is 16,807. And if I subtract the previous term, which is 117,649, I get negative 100,000. Okay, sure. Now, do I subtract that number from 3 here? Of course not. If I subtracted negative 100,000 from 16,000, I'd end up with a negative number. So clearly I'm not adding or subtracting, in this case, the same number each time. So I know that this is not going to be linear. What can I do now? Well, I can try to figure out if it's geometric. So in that case, that means I'm multiplying by some number each time. So that would mean that my n2 divided by my n1 would be my common ratio. So let me try this now. Let me take my n2, which is 16,807, and if I divide that by 117,649, I get this really tiny number, 0.142857, whatever. Okay? So now, if this number were to be multiplied by 3 here, or I'm sorry, by 2 here, if I were to take this number and multiply it by 2, it should be my 3. So let me go ahead and do that. So I'm going to multiply this by 16807, and let's see if I get 2,401. I do. So that means I found my common ratio. This number has a common ratio. Cool. And if I multiply this by, now this is truncated, I didn't do it all, but if I multiply this by 0.14287, I should get a number that's pretty close to 343. You know, I cut off a lot of the decimals, so it's probably not going to be exact. 242.9999. Yeah, so I'm pretty close. Okay, so I figured it out. This is going to be an exponential function. Okay, so I know that this is exponential. Ding, 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 ding. So what? What do I do now? Well, let's clear this red pen. Well, I have to look at my exponential function for my geometric sequence. And so I know that n sub 0 times my common ratio to the x, but I don't have my n sub 0. Okay? I don't have it. Now, I could figure it out, but then there's an alternate form for this. And that would be f of x equals our n sub 1, which we have, times our common ratio to the x minus 1 power. Every term we move over, if we just do minus 1, we'll get there. So the equation for this would be our n sub 1, so f of x equals 117,649 times our common ratio, oh gosh, which we figured out to be this tiny, tiny, tiny number, 0.142857 to the x minus 1 power. That would be good enough. Okay? And so that's pretty much what we're going to be doing for all of these. We're going to have to look at them, see if it's linear, exponential, or neither, and then be able to calculate it based on this good stuff. All right, let's move on to the next section. Reviewing key topics in statistics. This is kind of like what we did in class. So we're going to figure out if it's sometimes true, always true, or never true. And then if it's sometimes true, we're going to figure out when those examples are. So the first one is the linear regression line passes through the average of the x values and the average of the y values. And so what I want to do here is I just kind of want to think about this. What is the average of the x values? Well, that's x bar. And what's the average of the y values? Well, that's y bar. And this is always going to be true. The x bar and the y bar, you know, if we were to do some sort of point, and then we were to, where's another pen? Here's another pen. Draw a line. We would have x bar, y bar represented on the line. So this is always true. AT. Okay, that's it. And then finally, we're solving literal equations for x. And to solve a literal equation for x just means to get x by itself. So when I look at this, I see that x is not by itself. It's being multiplied by an a. I'm going to undo multiplication by dividing both sides by an a. So x equals d over a. Done. Same thing here. I see that x is being multiplied by a c and having a b added on. So first I need to subtract the b. This gives me cx equals d minus b. And now I need to divide by c. So x equals d minus b over c. Okay, so that's essentially what we're doing. We're just trying to get x by itself using all the tools we have to manipulate equations. Likewise, when we look at these ones, we're trying to solve for y. So I would subtract 4x. Y equals negative 4x plus 3. Boom, done. And then these ones are much more complicated, where we're trying to solve for a single variable. So this one we're trying to solve for r. Well, I see it's being multiplied by a pi. So if I divide by pi, I then have a over pi equals r squared. I want r by itself. I have to undo the squaring. So I have to square root both sides. So the square root of a over pi equals r. Okay? R is by itself. So each time we're looking at what's happening to the indicated variable, and we're trying to undo it. If it's multiplication, we do division. If it's division, we do multiplication. If it's addition, we do subtraction, etc., etc. Please remember to excuse my dear Aunt Sally. Make sure you're using your order of operations. All right, we want to undo backwards order, right? We want to undo addition and subtraction before we undo multiplication. So just kind of keep that in mind. All right, that'll do it. Good luck, and see you tomorrow for the big review.